Permutations and combinations are different, even though some people use them interchangeably. Combinations are a selection of given numbers or elements without regards of their arrangement. Permutations, on the other hand, are ordered arrangements of a set of objects, which are just a list where the order matters. For example, a combination lock should be actually called a permutation lock because the list of numbers are ordered. And how a list of ingredients are a combination because the order of the ingredients don't really matter. In this video, we will go over permutations with repetition, permutations without repetition, and combinations without repetition. I'm not going to explain combinations with repetition because, yeah. Let's first go over permutations. So what is the difference between permutations with repetition versus without? Permutations with repetition are permutations where they can have the same thing multiple times, while permutations without repetition can't have the same thing multiple times. So flipping a coin has repetition, while playing bingo doesn't, for example. Let's say you want to know how many possible outcomes you could get from rolling 2 dice. Well, you can graph it like this. Basically, when you have X varieties of a thing, you need to choose between X things every single time. So when you're rolling a die, there's 6 possible outcomes. And when you're rolling the second die, you add 6 more possibilities to every one of those outcomes. You can simplify this into an equation where R is the amount of choices and N is the amount of varieties. Now, let's say you want to know how many ways you could order 16 pool balls. So, if you were to do this manually, you would need to decide what should be first in your order. Let's say you pick pool ball 1. Now there's only 15 pool balls left. Now let's say you pick pool ball 2. Now there's 14 pool balls left. This pattern repeats till you have 0 pool balls left. Using what we learned, we could say that the number of permutations is equal to 16 times 15 times 14 all the way down to 1. So what if you want to know how many ways you could group only 3 pool balls out of all 16? Well, it's equal to 16 times 15 times 14. Well, how can we explain this mathematically? In order to understand the equation, you will need a basic understanding of factorials. Factorials are basically just multiplying natural descending numbers. Using that knowledge, we can simplify the equation to 16 factorial. But what if we only want 3? Well, you could just divide by 13 factorial. Dividing by 13 factorial cancels out, leaving 16 times 15 times 14. Using this information, you could form this equation. Let's look at the pool ball example again. But this time, we don't care about the order anymore. All we care about are which pool balls are picked. We know that 3 pool balls have 3,360 permutations. But because we don't care about order anymore, we can remove some of them. For example, let's say we pick pool ball 1, 2, and 3. These are all the possibilities. In fact, we already have a way to figure out all the permutations by just taking the factorial of 3. So all we need to do now is divide the permutations by the factorial of all the varieties. This is often called n choose r, where n is the amount of variations and r is the amount of choices. Permutations and combinations are used everywhere. It's usually used to find the probability of something happening. Permutations and combinations are also commonly used in competition math. In the 17th century, the French mathematician Blaise Pascal and Pierre de Fer gave rise to combinatorics and probability theory, which ended up creating permutations and combinations equations.